Hello everyone, I'm Peter, and in this short presentation, I'm going to talk you through the machine learning project I worked on. The project basically involved using statistical machine learning methods to predict either a mushroom is edible or poisonous. So the first thing I did was just to explore the data properly, and the data sets I used has over 8,000 mushrooms, of which each is described by 22 categorical features. And then on looking at the data set properly, I discovered that all the features are categorical, and therefore I made use of a lot of bar plots to see how different attribute levels are distributed. Then I also compared each of the features against the class label to see their proportion. And from here, some features stood out so well that they were able to partition the classes distinctly. That is, if you check out the odor feature, you check out the features on gills and spore print, they were able to show clear separation among the classes. Moving on, I also made use of the Cramer's V matrix. The Cramer's V matrix basically help in showing categorical association between variables. And from here, we can see the correlation between the categorical variables. Also, I made use of the MCA, which is the multiple correspondence analysis. And from here, from the multiple correspondence analysis, we could see that even before fitting any model at all, we can see that the data set is separable, shows clear separation. Now, after exploring the data, I had to decide what model to make use of. And because the data set is fully categorical and the pattern looked highly non-linear, I decided to go with the random forest. Now, the main idea behind the random forest is just that instead of fitting one complicated model, it builds on many decision trees, of which each of the train is trained on slightly different sample of the data. So basically, each of the trees learn simple rules, just like if the order is far, go to the right, otherwise go to the left. And then the forest combine all of these decisions through a majority vote. And since it's a great method and it handles interactions between the variable automatically without even specifying the features, I decided to go along with it. Next is to fit the model. And when the model was fitted, I made use of 400 trees and the usual rules for classification problem, where the model tries only a small random subset of features at each of the splits. Then after I noticed the out of the bag error, basically the out of the bag error is just like an inbuilt cross validation, and it dropped almost to zero just immediately after few trees. Looking at the plot, you can see that just immediately after zero, without even getting to 100 trees, it dropped back to zero. And that was what informed my decision, firstly, that the data set is mostly perfectly separable. And the forest did not even you didn't have to make use of up to 100 trees before it becomes stabilized. Then I also looked more closely at how the model was behaving internally, because each tree is trained on a bootstrap sample. That is, different trees sees slightly different version of the data set. But even with that randomness in the algorithm, the tree kept making the same early decision. Almost every tree began by splitting on odor because it produces a huge drop in the impurity, right? That is, it separates the classes extremely cleanly. So that was why it was able to come about that. Then the optimization process inside the forest ended up being very simple because the data has such a clear structure. And looking at the sensitivity of the model to tuning, I varied the number of variables the model considered at each split. And that error stayed at zero for almost every settings. Looking at it, we have that at every values of m try, which is a parameter in the model, it still remains as zero. And this confirms that the model is not just performing well, probably because of tuning or something. It's performing well because the pattern in the data actually is genuinely clear. And the next thing, I move on to evaluating the performance of the model. And looking at the evaluation metrics, we see that the results were perfect. Literally every edible mushroom and every poisonous mushroom were classified correctly. Looking at the ROC AUC also, which is 1. It means that the predicted probability for edible and poisonous mushroom didn't overlap at all, at all, at all. And looking at the variability importance also, looking at the graph of variable importance, you see that although the spore print color dominates this, which matched exactly what we saw during the initial EDA. At first, looking at this, it was kind of suspicious because having a model that has 100% accuracy, sensitivity, 100%, and it was kind of looking suspicious. But after looking at, statistical inference and the justification for this, we're able to come to a conclusion that truly, truly, it wasn't just, the model was not just acting out of luck or something. Like the data set is truly separable. And finally, I deployed the model using the Shiny app, and I just saved the model using one of the libraries in R software, such that each time somebody runs the model, try to predict, it won't retrain the whole data right from scratch. It just go and look for, it just looks into the trained model and then train it. And then the deployed application for testing is available on this link. Thank you very much for your attention.